Welcome to another episode of Are You Afraid of the Code? I'm A.M. Grabelny, one of your hosts for the channel, and we're kicking things off discussing our digital Ouija project. Now, eventually, Richard's going to turn what we build here into an IoT Ouija also. These episodes will be building in, and you'll know that we're building in an episode if we label it with the dev, null, and void title. So we're trying to give you a better insight into what each episode entails. Some episodes will be talking about the paranormal or other supernatural phenomena. Some episodes will be building. And this is one of those episodes where we are kicking off the build process. Richard needed to get up to speed on Golang. He had a lot of questions. I talked through some of that with him. But before we even got to start building on our Ouija, I wanted to give Richard an introductory course to Golang, and I did that with a very special part of medical history. I'm AM, short for Alan Michael. I'm one of your hosts here alongside your other host, Richard. We are going to be using Golang or Go as people interchange those things because it's really hard to search for Go. There's a lot of things that come up when you type Go into a search engine.
Especially when you're doing performance optimization. The number of times I say like how go fast and none of the answers are relevant.
Do you have any suspicions why I picked Go to build this first version?
I assume that besides C, it's the only language you know how to spell.
I don't even know how to spell C. S-E-E? Is that?
Yep. That's
S-E-A.
Nailed it.
That's a good guess. It is one of the simpler languages to spell. But no, I my initial approach with the Ouija board is I want a digital version, right? And me personally, I live a lot in the terminal. What is it? What's first off? What is a terminal? Should I pull up the terminal while we talk about it?
Yes.
I'm going to anyway. Even if you said no, I would have brought it up anyway, Richard.
Yep. And this is often called like the command line or the CLI. People will mix up like the CLI of like this is technically the command line interface to all of the stuff, but if some group publishes a tool that operates here, they call that the CLI. So it's like it's a term that's lost a lot of meaning. I don't want to say it's lost meaning. People, unless they're being like unnecessarily pedantic, they'll know what you mean. If you're like, oh yeah, open up the CLI. Maybe which CLI? But if they're like, if someone does that, like it's good that they do that because then you know exactly the kind of person that they are.
They've told you all you need to know.
Exactly, and if you knew that they were going to do that, if you didn't learn anything new by them doing that, then like you're asking for it. Like you brought this on yourself.
I like working in the CLI or terminal or command line or whatever you want to call it a lot because it's fast once you know how to do it. So if you first start working in it, it actually can be very challenging because there's a lot of commands. It's basically interacting with a computer through text, right? Through typing instead of clicking around in Windows and graphically, that you might be used to doing. I prefer it because I can do things very quickly, much like when I'm writing code or programming, right? So over the years, I've learned the commands that I use most often, right? PWD gets you a lot of places. LS is another good one. I don't have any files or folders in here, so you don't see anything. But yeah, so I like using the terminal because I'm
Is that the normal flags you use for LS, the -LA?
I do LA, yeah. What do you? Maybe an LAH.
Yeah, LAH is what I do. LS, LAH.
Oh, sorry, LS, not LA.
You're doing something else. You're also doing something, but like, and the only difference there is that it turns the size into human readable. So like that says like 64 bytes and 224 bytes. So that in mine without the H is the same because it's all in bytes. But if you had something that was like larger, that was like in kilobytes or megabytes, it would just list all of them in bytes, which is annoying. But if you do LAH, it'll say like 3 megabytes. It rounds and truncates, which I like. But it's a fun bit of trivia to know about someone of like the flags they use in LS by default.
Yeah, yeah. If I'm looking for a file size, I'll throw in the H. If I'm not, I won't, because it's more efficient technically, right? You're leaving off one keystroke. We can get into like a nerd fight about it. Like, I'm not always looking for file size, so I don't necessarily care how big the files are. But if I'm specifically looking for it, then I'll throw in that H.
Okay. I think the effort required to interrupt the muscle memory to not include the H would negate some of that.
Is more inefficient. Okay.
But
this is
we'll have to
what
do a study, a
look,
double-blind study.
This is why people don't like programmers, or people who.
Or I said like the pedantic person, like, oh, actually, technically, it's like, and then we both did it.
Yeah, of course. So it's your natural inclination once you start learning this stuff. It just breaks your brain. So be prepared. If you're learning how to code, if you're learning about computers for the first time, it will break you. It will change you into a human being that no one likes anymore.
And people will ask you to make them a website.
Yeah, or they'll tell you about this
Or an
great
app.
idea they have.
Yeah, I feel like making websites, that time has passed. Like that was like early 2010s. Yeah, I think nowadays it's like, I guess now it's probably like, I have this cool AI idea. I have this cool ML idea.
Yes, totally. I decided arbitrarily to make a command line version of a spirit board or a Ouija. Since that's a trademark term, we're not actually building a Ouija. We're building or Ouija, as you might pronounce it. We're building a spirit board.
The name we settled on last time was the Nono board.
The Nono board. That's right. Yeah, we did discuss the Nono board. The Richard Boyd Nono board, I think, is the full title. Richard Boyd presents the Nono board.
Yeah, well, you need it like the early 1900s style of like Richard Boyd's like Nono board Emporium extravaganza.
Yeah, so Go specifically, when you're making executables, right? Programs that can execute, programs that can run on multiple different operating systems, you generally have to package those up specifically for those operating systems with special, compiling, or even you have to build it on the system. Go doesn't work that way. Go can compile for multiple operating systems for you from its built-in tooling, right? So I can make a version of the Spirit board that'll run on a Mac OS and on a Windows machine, all using Go's built-in compilation and build tools.
And this is where one of those pedantic nerds would interrupt you and say, it's not executable, it's a binary. And the type of binary varies depending on the operating system.
EXE.
Windows, Windows, it's an EXE for executable, but like on Linux, I believe it's an ELF binary is the official technical. I think according to the Linux kernel book. Another part of being a programmer, you need a bunch of books you've never read that just make it look like you know this stuff.
Yeah, absolutely. Thank you for the
my understanding with Go is that it doesn't. So for other languages, it'll compile it all the way to the binary that then executes. But with Go, it doesn't do that. Like what I thought I remember hearing that like, one of the criticisms is that like it has to like fetch and rebuild fairly frequently. So like you're giving a intermediate build object when you pass it around or when you publish it for other people to use. Is that accurate?
No, it's self-contained. Like you, at least my understanding, which maybe I should Google a bit as we talk. No, my understanding, and I've used it. Once you compile it for a target operating system, it works on that operating system. You don't have to have anything else installed. It's self-contained. Now, what's inside that binary? That I don't know.
Oh, is this? I'm not like a formally trained. Is this like static linking versus dynamic linking? Is that like the difference of like everything that needs it pulls in? It's like fully in there. Whereas like dynamic linking is like the issue with like Windows. Like, oh, you need like a DLL, which is like the dynamic link library, and it pulls in the C headers or something along those lines. Okay, I just wanted to make sure I understood. So you're saying you can compile Go and like target, call it cross compiling, like
Yeah.
target some operating system, and then it'll work on that one.
Yes.
And it doesn't matter what they have installed. Like they don't need, say, like the Go interpreter, or Go
No,
runtime on that
it's
machine to
not
run
like
it.
Java, right? So like Java's a good distinction here to use, because Java runs intermediary code, or bytecode is what it's called in Java, on something
Yeah.
called the JVM, or Java Virtual
Yes.
Machine, right? So you compile to bytecode, and then in order to run that bytecode, you have to have the JVM installed on whatever operating system you're going to run the program on that you wrote in Java.
So it's like, and like Python, right? Because Python, like you have a Python
Python's
file,
even
and then
different, I
because
believe,
you
because
because you
that's
can give
at
someone a Python
runtime.
file, right? And they need a Python interpreter on their machine.
Right. Yes. So
Right.
that's even separate from this, because Python is interpreted at runtime, right? So you load in the actual code. Uh, you're not loading in like the Java code that you wrote. You're
Yeah.
still loading in an artifact that you built
The dot
using.
class files, right? The devalik.
Yeah,
Yeah.
yeah. I mean, it depends on how you're loading it, right? Like generally for Java, there's like an archive, like a jar file, they might call it, a Java archive. Or if you're uploading it to like a web server, it might be called a war file. You might have seen those in Java. And then those contain the bytecode that then gets loaded into the JVM that runs on the operating system. With Go, you get a single binary. Yeah, so you can change the target architecture, you can change the target operating system, and compile a binary for each of those. So it's very. This is why a lot of developer tools are built in Go, because oftentimes you're supporting developers running on multiple operating systems, right? So you mentioned Linux. That's a popular environment for developers. Mac OS is also very popular with developers, and even Windows. Yes, Richard, even Windows. Some devs use Windows. So if you have a tool that you want to work across all of these different operating systems, Go might be the right choice for you, because you won't have to worry about how to compile for each of these different operating systems. But these are non-graphical applications that we're talking about, right? Once you start adding in Windows and not the operating system, but
Yeah. Lowercase w Windows.
yeah, lowercase w. Once you start adding in graphical components, it gets more complicated. That's when you start needing ties into these other libraries existing on specific operating systems. Like I said, because I want to be able to ship this Spirit Board CLI tool to anybody, basically.
Yes.
And the Go gives me a really easy way to do that. Go's also pretty easy to pick up. Go was built by engineers from Google. I could look up their names, but I don't remember offhand. And I didn't think we get into the history of this stuff. We can, but
William Go and his apprentice Billy
well,
Go.
he's Bill Go to his friends.
Yeah.
Bill Go Baggins, I think is his full name. It's terrible.
Frogo.
It's real bad
Frogo
joke.
Baggins.
Yeah, no, so Go is very simple in terms of the language features, except for a few of them. A few of them take a little bit of getting used to and a little bit of extra learning. Go is also built to handle a concept in programming called concurrency very well. And concurrency is, generally speaking, in a lot of programming languages, a complex and difficult topic to really fully wrap your mind around, and how the different mechanics of your program work when you're building with concurrency.
You mentioned that like it, I think the way you described it is like it's centered around concurrency. Is that like one of the, I don't want to use like these big like design paradigm in terms of like the language is like usually languages are binned according to like, oh, it's functional or it's
Right.
what's the other?
Object oriented.
Yeah, object oriented, and I can't remember the other, declarative, imperative, like a lot of these like
Yeah.
styles where the language designer has said like this is how you should this is the way you should write code. And for some languages, that style, it ends up being named after the language, right? So you get like, was it like Lisp style like functions and things like this. Is Go meant to be like concurrent first, like concurrent native? Like it's, you should be doing as much stuff concurrently. Is it like the way you'd say that like F sharp is a functional language? Is Go considered like a concurrent language, or is that just like one of its
It's a,
strongest?
it's definitely a key characteristic, and I think it's honestly because of how concurrency was developed in Go. So Go does not actually make use directly of threads in its concurrent pattern. So threads are at the heart, right, of concurrency for Go. But you, as the Go programmer writing Go code, are not allocating from a thread pool like you would in other languages that use concurrency.
Java.
Right, exactly, just like Java, right? So you have the actual threads that are, a part of the processor, your CPU, that you are allocating from in Java. That's not how it works in Go. Go has an entire scheduler that you then schedule what are called Go routines. They gave them a little kind of Go related name there. They call them Go routines, which is kind of a play on co-routines, I think, from other language concepts. But a Go routine is much, much more cheap to instantiate than a full-on thread in terms of resources. But it also has it's got some trade-offs. It's got some benefits. But when you are programming in Go, as we'll see, to make something concurrent is super easy. You just write Go in front of a function name. That's it. So if you write a regular function, you don't have to do anything special to that function. If you put
No
the
async await.
No, nothing. If you put the word Go in front of the function as you invoke the function, it runs in a separate Go routine from the main Go routine. And then the scheduler underneath goes in and it allocates it towards the threads that are available based off of your CPU architecture.
And is that allocation, is that done at compile time or runtime?
Runtime, I believe. The scheduler is running alongside like the garbage collector and all of those things. So, but what's cool is that since it's a statically typed language, meaning you declare out all the types, it knows about all of the types. It's not like a Python that's interpreted at runtime. You can actually, in the build stage, use this data race detector to see if you've done concurrency. It doesn't always find all the data races, mind you, but you can use it to find these kind of difficult, typically to find pitfalls that you might run into or problems that you might run into when you're actually doing concurrency before you get to runtime, right? Before you go and deploy your software somewhere. So it can help you troubleshoot before you even get into trouble. Yeah, we're going to see a bunch of this. Go is an interesting language. I think it's funny that you brought up, a lot of people when they're designing languages, they make choices and designs and say, this is how you should do that. Go enforces that at the coding level. So Go actually has this part of it called Go format or Go funct.
Yeah, go funct yourself.
Yeah, exactly. We don't have any Go code yet, so it's not going to work. But this command actually goes in and so instead of having the eternal debates on tabs versus spaces or where does the curly brace go, or should I have semicolons or not? Go just said, no, you have to do this or your code won't compile. And we will write this formatter that will just go in and change your code. So they made a lot of design choices where they just said, shut up, nerds. I think that was kind of their argument when designing the language, was just like, the nerds need to shut up and just do it this way. So for better or for worse, and we'll see some of those choices and how they impact. So for example,
if you don't run Go format, like, can you still compile and build and run the?
Nope.
Good.
Not
That's
if you have
interesting.
things that are breaking the conventions of Go.
Interesting, because
Yeah.
they I've seen in some like language design discussions where like there are like weird like, oh, why did the language choose, when you ask some of these people who have designed languages, like, why did you choose this, like this specific like algorithm inside like the lexer or the parser inside the compiler, and like, oh well, like if you had a function that was named in a certain way and you had this and like if these conditions were true, this thing in the code would be ambiguous and the compiler wouldn't know where a token stops or starts, or like like what the appropriate semantics are of this.
Yeah.
So you end up with like some of these kind of weird hacks in the compiler to like make room for that. It's interesting that it's okay, curly brackets must be on this specific line, and like I like that. It simplifies a lot of this.
It makes the discussion stop, if nothing else, right? Like, it makes the stand-ups where, it's gone 15 minutes over already because these two people are having a knockdown, drag-out fight about semicolons and whether they should or shouldn't be present. It makes those discussions not happen because there's no choice.